Alright, in this lesson I will be adding radicals. Now, in order to add radicals, they have to have the same index and contain the same terms under the radical. Now, when I begin, I'm going to be taking out all the perfect roots of these numbers in order to simplify them down in an attempt to make them look the same. Alright, let's do a few examples. First example, square root of 12 minus square root of 27 plus square root of 75. Now, all these numbers under the radical are different, so I'm going to try to find the perfect squares that are the largest for each of these numbers and rewrite these. Largest perfect square that is a factor of 12 is 4, so I will write this as square root of 4 times square root of 3 minus largest perfect square that's a factor of 27 is 9, so I'll write that as 9 and 3 plus largest perfect square that is a factor of 75 is 25, so I will make that 25 and 3. Now, all these perfect squares will simplify into numbers, and then they will all be followed by a radical 3. Square root of 4 is 2, so I get 2 square root of 3 minus square root of 9 is 3, so I get 3 square root of 3 plus square root of 25 is 5, so I get 5 square root of 3s. Notice all my radicals match up, so I'm going to add the numbers in front and keep the radical the same. So 2 minus 3 is negative 1. Negative 1 plus 5 is 4, so my answer is 4 square root of 3s. Okay, next example. We're going to do 2 square root of 50 minus 3 square root of 125 plus square root of 98. Now, the thing about this is, since these two got numbers out front, any perfect squares that I bring out, their numbers will get multiplied by the numbers that are out in the front. Let's go. 2 square root of 50, I will make 25 and 2, since 25 is the largest perfect square. Then I got 3. 125, I will break into 25 and 5. Once again, 25 is the largest perfect square, that is a factor of 125. And then plus largest perfect square, that's factor of 98 is 49, so I'll make that 49 and 2. Alright, these two numbers have a square root. This gives me 2 times 5 square root of 2 minus 3 times 5 square root of 5s plus 7 square root of 2s. Now, order of operations says we got to multiply these two terms before I can add and subtract. 2 times 5 gives me 10 square root of 2s minus 3 times 5 is 15 square root of 5s plus my 7 square root of 2s. Notice the only like terms are the square root of 2s, So we'll add them together. 10 square root of 2's plus 7 square root of 2's gives me 17 square root of 2's minus my 15 square root of 5's. And y'all, that is my final answer. Alright, my last example. Square root of 9b cubed minus square root of 25b cubed plus square root of 49b cubed. Now notice, all the numbers are perfect squares, so they'll come out. Now, what I do when I got variables is I take the index and divide it into the variable. Ever how many times it goes into it, that's the exponent that comes out. If I have a remainder, it stays under the radical. Here we go. Square root of 9 is 3. Now, remember, all these have an index of 2. Okay? Now, 2 goes into 3 one time, so I bring out 1b. Alright, with a remainder of 1b under that radical. Now remember, technically those have an exponent of 1 by them. Minus square root of 25 is 5. I got a b cubed again, so that's going to come out as a b square root of b. Plus at the end, square root of 49 is 7. And then once again, 2 goes into 3 one time with a remainder of 1 under the radical. Notice, I now have b square root of b's, b square root of b's, b square root of b's, which are all like terms, so we add the numbers and keep the terms the same. 3 minus 5 is negative 2. Negative 2 plus 7 is 5. So final answer is 5b square root of b. Alright, now one of the main things you want to realize on these, once I got the radicals looking the same, I did not change them. I just added the numbers in front. Until next time, goodbye.